For today's lesson, you are locating P5, Rational Expressions, Part 2. This particular section is divided into 2 days of instruction. Welcome to day 1, where we multiply rational expressions. You will see that there is a warm-up right there at the top. Now, if you would be so kind as to allow me the opportunity to get you going on this warm-up. Maybe you haven't multiplied in a while, particularly with fractions. So it's mutually beneficial for us to just give the warm-up a little love together before we get all into the lesson today. So there are 2 schools of thought with regard to multiplying fractions. The first is, what a lot of students like to do. They will, so this is plan A, where you can multiply straight across the top, multiply straight across the bottom, and then reduce. So if we do 4 times 1, that's 4. And then if we do 8 times 3, that's 12. But you can't leave me an answer that looks like that, right? You got to reduce. Yeah, so we would reduce out the common factor of 4. 4 goes into 4 1 time, and 4 goes into 12 3 times. So the answer is 1/3. So,
8 times 3 is 24.
wow, I need a nap. Why did I say 12? Scarlett got it, though. She's the candy winner. Apparently your math teacher forgot how to multiply. That is what's happening.
I have a question.
Details.
Instead of doing 4 8 times 1/3, could you have done 1/2 times 1/3?
That was going to be my plan B. Good job, Alexandra. Okay, but I got to get through plan A first. So 4 times 1 is 4. 8 times 3 is 24. Thank you to all of those who snapped me out of my autopilot foggy moment there. 4 goes into 4 1 time. 4 goes into 24 6 times. So embarrassing. I am actually recording this lesson, so the folks at home will get a big chuckle out of that. Whew, I got nervous. Like the dumpster, I don't know. All right, Alexandra gave us a plan B.
Are our voices on that?
No, it's just me. So you see this 4, although I just said your name, so that'll be on there for all of eternity.
Aw, that's nice.
So 4 and 8 share a common factor. And remember from yesterday's lesson, you can reduce from top to bottom. So 4 goes into 4 1 time, and 4 goes into 8 twice. And then you could multiply these numbers. So we would do 1 times 1, that's 1. And then 2 times 3 right there, that's 6. So potato, potato.
Oh, I like that.
You get 1/6 either way. Okay, wait, it gets better. The one I wanted to fast forward to a little bit is actually a problem like number 3. Okay, those of you with a calculator handy would consider maybe just multiplying straight across the top, straight across the bottom, and then reducing, but allow me to show you a cool trick. You can reduce first, exactly, yeah. So for instance, I noticed that 144 and 24 share a common factor of, 12 for starters, but also 24. 24 goes into 24 1 time. Yeah, and then 24 goes into 144 6 times. This phenomenon is called cross-canceling the common factor. So you basically cross-reduce, or you can reduce across the diagonal. That is a huge idea for today's lesson. So do you see what I did there? I reduced out across the diagonal the common factor of 24. Can anybody tell me what I would reduce out of my other diagonal?
13.
Nice. It is 13. 13 goes into 26 twice. 13 goes into 169 13 times. And now I can multiply straight across the top, straight across the bottom, and I didn't need to use a calculator. 6 times 2 is 12. 13 times 1 is 13. So 12/13 is the answer to that problem. All right, if you want to take a few more minutes to finish up this warm-up. It is. I like it. It's time-saving, brain-saving, all the savings. But yeah, you have those next 3 to finish on your own, and then we'll go over them in like 0.2 seconds. I'm going to walk around and answer individual questions about the homework. First, Chickadee, check your warm-up, please. Did you get the problems correct?
Yes.
Oh, good. That is happy
Does
news.
1x over 3 count?
Yeah.
Yeah, it does. Okay.
Huh?
Yeah, so 1x over 3 is legit. So is x over 3. But not 3 over x.
And above
Watch
is
yourself. Alright. Anybody else have any questions about the warm-up? I kid you not, the exact same thing we do with numbers, we now are going to do with rational expressions. The algorithm doesn't change. We break things down into their factors, and then notice today we're going to be allowed to cancel in not one, but 2 directions. Not just top to bottom, but like in number 3, across the diagonal. That's it. I have 1 new direction to cancel in. The lesson is identical to yesterday. So giddy up, kids, do it. First of all, just a little reminder, in general, when you multiply rational expressions, like A over B times C over D, you are just allowed to multiply straight across the top and straight across the bottom. So we would say that A times C would be your new numerator, and that B times D would be your new denominator. This is, of course, as long as you don't divide by 0. So if B and D are 0, all bets are off.
Everything's just 0, right?
No, it'd be like undefined, and I'm pretty sure the planet Earth would explode and the bad things would happen. We'd all fall into a big asymptote. Yeah, it'd be bad. Super bad. Let's never speak of that again. Okay, so in example 1, we are asked to multiply the following expression, and we got to write our answers in lowest terms. So please don't leave me anything like 4/8 as an answer that is not in lowest terms. So you got to reduce out all your factors. I know. Okay, so I'm going to go ahead and write the steps down just so you have them to refer to. You just have to write them down once. They're not even really sentences. They're just like verbs. So verb number 1 associated with step number 1 is to factor. So we factor really everything we see. Every numerator and denominator. So if you have x squared minus 2x plus 1, you might recall from yesterday's lesson that factors to be, oh dear, my stylus stops working. So we have x minus 1 times x minus 1, because those are the factors of positive 1 that make negative 2. On the bottom there, I'd probably just go ahead and GCF that.
Oh, we have to. Oh.
So if I GCF x cubed plus x, they have an x in common, right? So this will be x, and then x squared plus 1 times, so I'll bring down my little dot there. And now I have to factor 4x squared plus 4. That I'd also take a GCF out of, so that'd be 4. And then x squared plus 1. And then last but not least, I would factor x squared plus x minus 2. That factors to be, so factors of negative 2 that make 1, 2 and 1. But the 2 should be positive. And the 1 should be negative.
So, yes, so yes.
Yeah.
So, wait, why did you, for the 4 and then parentheses, x squared plus 1?
Uh-huh.
Oh.
I pulled out the, see how they have the 4 in common? Yeah.
Oh, I didn't, okay.
And then if you distribute that 4 back in to check yourself, 4 times x squared gives you the 4x squared, and then 4 times the 1 gives you the 4.
Okay.
Yeah.
Thank you.
Sure, happy to help. Okay, next up. Sorry, I'm like into the color coding right now. So that numerator there was that first part. Okay, so now this is my favorite part. Because I can cancel stuff that's the same. Remember, today we're canceling in 2 directions, top to bottom, across the diagonal. So I go ahead and I just look top to bottom first, and I'm like, okay, can I get rid of anything in the first rational expression? In other words, use the skill set from yesterday to make this first fraction easier. The answer to that question is no. Nothing is the same on the top and bottom. Then I bounce over to the second rational expression. I'm like, womp womp. Cue the sad trombones. There's nothing that cancels there either. Nothing that makes my life a little easier. So now I'm going to go ahead and look across the diagonals. And I just happen to notice that there's an x minus 1 in both. So I can get rid of those. And remember, it's not like I'm sprinkling pixie dust on them and making them vanish. Eventually, in the problem, I would have the x minus 1s over one another if I multiplied, and that makes 1. So these slashes are 1s. Like if you want to think of them as a 1 now, that orange mark, you could think of it as a 1. That's completely algebraically legit. What's up, Tristan? You see something else?
Yeah.
What is it?
The x squared plus 1.
Yeah, giddy up. Did you have another question?
No, that was it.
Oh, I thought I put words in your mouth. I got worried there. So what was this step 2? After I factored everything, I canceled in 2 directions. So step 2 is to reduce. And you can reduce today in 2 directions. Direction 1 is from top to bottom.
I just drew the perfect arrow.
You're good with that. Tristan font.
Look at this arrow.
And direction 2 is across the diagonal, so or diagonally.
Arrow.
Alright.
Diagonally.
Use.
Okay, last step. Step 3. It's actually really easy. It sounds complicated, but it's totally not. We multiply, and when we multiply, basically that's just fancy talk for like write down what you have left. Because we just multiply straight across the top and straight across the bottom. So across the top, I have x minus 1 times 1 times 4 times 1. In other words, I have x minus 1 and 4. The cool kids are going to write that as 4 times x minus 1. And then across the bottom, I have an x times a 1 times an x plus 2 times a 1. In other words, I have an x and an x plus 2. So the cool kids would write that as x times the quantity of x plus 2. And that's it. That's done. The end. Congratulations. You successfully multiplied 2 rational expressions. So now we just practice it. I make the factoring a little bit tricky, but that's your 3-step algorithm. Factor everything you see. Cancel in not 1 but 2 directions, top to bottom and diagonally. Step 3, write what you have left over, and that's your multiplying step. Questions about the algorithm? All right, let's just make sure it gets shoved into our brains. Like, oh, what's up, Michael?
Why don't we factor something?
So what I hear in your question is you have a wantingness to reverse our steps a little bit and then multiply and then factor. But what you would end up with is if you multiplied some of this stuff together, I mean, think about it. If you had to multiply all of this together, you'd have a trinomial times a binomial that's a degree 3. You'd end up with like really big polynomials that don't factor nicely. So you wouldn't be able to get an answer in lowest terms. It would be really hard. This way, way easier. Good question though. I like the thinking. The wantingness to have an easier way. I like that. That's actually a good thing. Alrighty. On to the next, my brainiacs. Okay, so I'm going to go ahead and factor the top. So step 1 is to factor everything. Anytime you see these weird exponents, lots of letters, that's my like way of saying like use the GCF method to make life easier. So see the g to the 4th, g to the 3rd, that's your cue to take out, so yeah, 5g to the 3rd, for sure. 5g to the 3rd times g would get us back to 5g to the 4th. Yeah, you're right. It's just 9. Let's go. All right, and then on the bottom, you gotta take out a g. What up, g? All right. And then you got g plus, this is a dangerous example because g's and 9s can look a lot alike. I'm like treading on thin ice here. So that's g plus 9 there. Ooh, I already see things that are going to fall off. Makes me happy.
Like it.
We can cross out the g plus 9.
Yeah, but I'm going to save it for later.
Yeah, right, you're right. Factor first.
Yes. I stick with my algorithm because if there's something easier to factor, I'll do that instead. So negative 4g, that can stay there. And then we got this negative 16g squared plus the 24. What to take out of that? Remember, if this is negative, though, you want to take out the negative.
Oh, you do?
Yeah, because it'll end up like not canceling if you wanted to. And then negative 8g, right? Ooh, And I need to remember to give Scarlett candy. I like them forgetting. So what do we got here? Negative 2. Oh, I'm sorry. Yikes. So I got 2G and minus 3.
I don't think it's that funny.
I know, right? Rude. Okay, now I'm going to go ahead and start canceling some stuff. So I start top to bottom first. So for instance, this G here, bloop, is going to turn the G to the third into a G squared. So I took out a G out of the top and bottom of the first fraction. And then more than one of you, I think, said, get rid of the G plus 9. So I will oblige.
I don't even know you could do that. Like you cross out the G and then cross out the cube. and
Yeah.
put it as a square.
You can do it here too, like this G and this G.
What?
G over G is just 1.
Interesting.
It's not bad.
So it's,
Well, then the negative 4 and the negative 8 too, those reduce.
what? Oh, yeah.
2.5.
Yeah, so this would be 1 over 2 because it's a half. So in the first part of the fraction, I have 5G squared. And then all of these slashes are just 1s, really. So 5G squared times 1 times 1. That's just 5G squared on the top there. And then along the bottom, 1 times 1 times 2 times 2G minus 3. So that'll give us 2 times 2G minus 3. There it is.
Whoa, this is hard to read.
Aww,
That looks like a lot.
my screen froze.
Interesting.
Oh, it's coming. Yay.
What?
Okay, questions about part B? All right, you got 2 down, we got 2 to go. You're gonna make it. Oh no, you can grab some notebook paper and then just take a picture, add it in. Notebook paper's in the blue basket. Help yourself.
You can borrow my charger if you want. It's a fast one.
I still have a charge.
There's fast chargers?
Mine's juiced up.
Why did I know that those things existed?
They like the big block.
Oh, I did see a big block today. It looked like tofu.
Yeah.
I was like, what is that?
Did you say that an iPhone charger went tofu?
I guess the fast chargers, the ones that have like that big, it's like a big block that like literally, it was white. It looked like, did you ever buy a Cuba tofu?
Maybe like this big.
It was huge. Yeah, it could feed a hungry family. Like,
There's one
it's
too
big.
for the iPhone. Like people can just buy like a really big one
Why?
to charge it really fast.
Yeah, I guess that works. Out of the bottom, by the way, that first numerator didn't factor. If you're working ahead, negative 5p, nope, doesn't factor. But the bottom, remember when you have that negative leading coefficient?
-1.
Yeah, you gotta pull the negative out. Nice.
Thank you.
And then that's all that one has in common. So that's just gonna be p cubed plus a 3c.
I see.
And then I'll go ahead and factor this guy up here. So I'd pull out the negative and the c. This one actually factors down to be pretty cool looking. I know that's probably hard to believe, but truth. All right.
Wait,
You can
negative
factor out the
C.
C. Oh.
Well, because it's negative, and then
Oh, yeah, but why is it
both of these things are negative, and then they both have a c in common.
Wait, what about the P?
There is no p in common. Visually deceptive. This doesn't have a p, so I can't pull the p out.
Alright, I see.
Wait, I'm confused. Why are
Because
you taking out C?
there's 2 C's in common and there's no any P in common.
Yeah, but like I thought you always had to have like everything in common before you take something out. Yeah, but like say if I had like 3 and then 9 and then like and then maybe like 7. Like I can't take out a 3 because there's a 7 in there. That makes sense.
Yes.
So I can do that with numbers, letters.
So with regard to 3, 9, and 7, you can't pull out anything in common because there's nothing in common.
They all, well, just 2 of them.
But this does have something in common, and that thing in common is the C.
What's the P doing there?
So we can't pull out a p, Annabelle. You're absolutely right. You can't because it's not in common. It's not in both
So it
things.
doesn't matter, like the p doesn't really matter.
Right.
Okay.
Yep.
Sorry.
You're only looking, when we look for a greatest common factor, you're only looking for the common things, the things that are the same in both.
Oh. Oh. Oops. Okay.
You're good?
Okay.
So I would go ahead and pull the p to the third out. Or I'm sorry, I said that wrong. Put the p to the third back in because negative c times p to the third gives you negative p to the third c. And then I already have the negative out in front, so this is going to be a positive 3c. Good job. And then on the bottom there, again, you can't factor the negative 5p squared, so that can just come down. All right. I'm going to take a little audience participation here. What do we want to cancel? What do we want to get rid of? Go ahead, Lizzie. Oh, show. Let's get rid of that. Let's get rid of that. What else?
What's your daughter's name?
I got 2.
No, your name's Stephanie.
It is. How do you spell it? No, I'm just kidding.
I still know how.
S-T-P-A.
Oh, wow. She just that is the only way to spell that.
My cousin has
S-T-P-H-A-N-I-E. Yeah.
My cousin has that.
It's a good name. What is it? Yes, the negative 5s. I like it.
Your daughter's named Sarah.
No.
Um,
No. This is an interesting game that y'all want to play right now. What else cancels? Oh, Tyler. Yeah, the P. Let's get rid of it. So this P here is going to turn this P into P to the first. Watch out for that. I can get rid of one more thing.
oh, there's 2 negatives.
Ah, there's 2 negatives. Good job. Nice eyeballs. So that goes, and then that would be positive.
Go.
So really, you got to look carefully. You know, these are just ones. And then I have C. And then this here went away. So really on the top, all I have left is a C.
I want to look at this later. I'm so confused.
And then on the bottom,
It's just 4.
it's just P, yeah.
Or P.
So C over P is our answer.
We got 6 minutes to do D.
I think we can do it. And then, where is it? Oh, it's down here. Okay.
Okay.
You
How
can cross
about,
out-
do you guys want to race me?
You can cross
Yeah.
out X.
Oh my god.
Okay. Ready?
You can take out X.
Set. Go.
Annabelle.
Sorry.
Oh man, the numerator factors twice on this one.
Oh my god, wait.
Because x squared minus 4 goes again. Boom.
I might be. So
I hear ferocious tapping. Academic weapons, as Tristan would put it.
I am an academic weapon.
Don't lie to yourself.
Savage. Oh good, I see something that's going to cancel. That's a relief.
Alright, I can take out you.
Oh my. Oh, that's disappointing.
Hey, let's go.
I don't know if it's right, but.
Alright, so what am I getting rid of here?
I finished. I don't know if it's right, but
Fine.
I'm gonna.
Tristan,
I'm
you
gonna
don't
put
have
it
not
on.
finished.
Yeah, I did. Do you see my answer
did.
circled?
Oh my god, we have 2 very different things.
Yeah, I might be
Holy
wrong.
moly.
So this is the factored
I
version.
might be wrong.
I didn't
because
cancel yet.
Since I wanted to be the teacher, I took a lot of shortcuts.
Oh, I didn't factor
But
it.
I might have skipped.
Did you? Who finished? Who said that?
Me.
I finished.
Well,
You did,
I've
Van.
been finished.
Did you beat me?
I've been finished. but
Oh,
I'm
dang.
still
I took out a GCF. Miss
I'm just
Lucas.
putzing over here.
Miss Lucas, can I take out a GCF instead of factoring?
That's the same.
Oh.
GCF is a method for factoring. It is, it is.
Wait, I'm so
Ooh, it is x squared.
What?
1 over x squared.
Devin was going on a rant today.
Oh.
Like could beat Jason was
I
saying
can give
that
a-
he's
How do
sport.
you can be
How do you do that?
sport?
How to do what?
Devin's
No,
saying
how
that.
to time
Devin's so worse at
Well, it's not done if you have the 1 over x squared is just a way to
Is that your
I
answer?
have what you have right now.
1 over x squared, like out in front. Like if you had a 1.
Okay.
just leave that out, Miss Lucas, just.
Oh, that's right.
IF has better.
Yeah, check if something gets goobered up, usually it's with the factoring. And then if you're good on this one, you have the independent practice, then you're done.
Whoa, whoa, whoa.
Whoa, 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 whoa.
Can you come here for a second?
I can. Let me make some rounds here. Alrighty, that looks good. We got an independent practice. Practice.
Speed run it.
Oh,
See you tomorrow.
see ya. There's your answer.